Problem number 12. We're told that this polynomial has a solution of negative 3i, and we want to completely factor this polynomial. So what do we do? Well, we first use the complex conjugates root theorem to say that if we have a solution at negative 3i, we also have a solution at positive 3i, the complex conjugate. And then we use the linear factorization theorem to say if we have those solutions, we have a solution of x plus 3i from that first solution and x minus 3i from that second solution. And then we FOIL and we say x times x is x squared, and we recognize that we are multiplying conjugates together, so the middle term will disappear and we'll be left with 3i times negative 3i is negative 9i squared, which we're like, imaginary numbers, they don't faze me. X squared plus 9 has to be a factor. And then we long divide. We're going to divide our polynomial y by x squared minus 9. So 2x to the fourth minus 5x cubed plus 15x squared minus 45x minus 27 is fun times. So we ask ourselves, x squared times what is 2x to the fourth? Well, x squared times 2x squared is 2x to the fourth. But 2x squared times negative 9 is minus 18x squared. And then we get that awkward space in the middle where we know that dude's going to come down and we're subtracting everything. So we say 2x to the fourth minus 2x to the fourth is happy face, 0. And we say negative 5x cubed minus 0x cubed is just negative 5x cubed. That dude just came down for the ride. And then we say 15x squared minus negative 18x squared is actually 15x squared plus 18x squared. And then we cry because 15 plus 18 is hard to do in our head. But then we remember that 15 plus 15 is 30 plus 3 is 33. X squared, and then we wipe the tears away and we bring down the minus 45x, and then we play the game again. We say x squared times what is negative 5x cubed? Well, we know that it's negative 5x, and we say negative 5x times x squared is negative 5x cubed, and we say negative 5x times negative 9 is a positive 45x. And we draw our subtraction line, and we put an arrow indicating that that 33x squared is going to go along for the ride, and we put our parentheses to remember that we are subtracting the whole thing. And we say that negative 5x cubed minus negative 5x cubed is happy face 0. And we say that 33x squared minus 0x squared is still just 33x squared. And fortunately, we know that negative 45x minus positive 45x is 90x negative 90x. And this is where Mr. Reed's like, wait, did I make a mistake? And I realized that I did make a mistake because we're just said that we're dividing by x squared plus 9, not x squared minus 9. So we better fix some stuff real quick. 2x squared times a positive 9 is a positive 18x. So 15x squared minus 18x squared is actually a minus 3x squared. So this is a minus 3x squared. And now we're happy because negative 5x plus 9 is a negative 45x, and negative 45x minus negative 45x is not a disgusting negative 90x. It is a happy 0x. And now we can bring that minus 27 down and finish this problem without tears, because we can again say x squared times what is negative 3x squared, and it has to be negative 3. And we know that negative 3 times x squared is negative 3x squared, as expected. And negative 3 times 9 is negative 27. And we don't have an x term, so we have that. And we are happy because we don't have a remainder. But we are told that we want to completely factor this. And so we now have this quadratic. 2x squared minus 5x minus 3. And we're told we need to completely factor this, so we need to factor this. And so now we kind of have to be careful and say, well, how do I factor this? Well, to get a 2x squared, I'm going to need a 2x and an x. So now how do we play the game? Well, I know that these numbers have to multiply to negative 3. So I'm really only going to have the options of 3 and 1. One of them being negative, one of them being positive. Negative 1 times negative 3 is negative 3. 2x times negative 3 is negative 6x, and 1 times x is positive 1x. Negative 6x plus x is negative 5x. So I've factored that, which is sick. But I'm going to be gross and do it more. I'm going to say pull that 2 out and write that as x plus 1/2. And then we have my x minus 3. And then we have the factors that we started with, x plus 3i and x minus 3i. And this is our equation, y equals bloobity. And we have completely factored the polynomial into 4 linear factors.